Hello, this is Joseph Drust, and in this video we're going to be covering one of the new and extremely powerful features inside of ZBrush 4R4 called DynaMesh Subtract. Now in the 3D industry you're often told to stay away from Boolean operations. These operations generally cause holes and other geometry issues with your mesh that can cause problems in a production environment. With the addition of DynaMesh Subtract inside of ZBrush 4R4, this taboo no longer exists. Using DynaMesh Subtract, you can now create precise, complex shapes extremely fast and extremely quick. Here we have two quick objects that were created using this method. We have a Picatinny rail, and then we have the top of a military radio. Now, if you look at these objects, they're extremely complex. These shapes would have taken me days to model inside other 3D packages. But now with ZBrush 4R4, these shapes can be created in a matter of minutes. This feature, DynaMesh Subtract, will not only help increase the speed of your production pipeline, but will also bring back some of the fun of modeling extremely complex hard surface objects. So here's the basic principle behind DynaMesh Subtract. If we take a simple object, using DynaMesh Subtract, remove a subtool from it, we get a new object. So taking this beveled rectangle here, punching out a cylinder, we get this shape. Then taking that shape, punching out another cylinder, we get this shape. So using DynaMesh Subtract and removing these objects from our main object, we end up creating this extremely complex and precise shape that requires no cleanup in a matter of seconds versus a matter of days it would have taken to do in another 3D package. Now here's a quick example just to show the basic principle behind DynaMesh Subtract. Here I have just an object here, and it's just a poly mesh object that was then distorted some, and then I've inserted in all these random cylinders. Now I want these cylinders to punch through this actual object. If I turn my polyframe on here, you can see that they're all right now consisted of different polygroups across the entire mesh. Now the first thing I want to do is I want to isolate all these cylinders as one polygroup, and using DynaMesh Subtract to punch it through this object. So first I'm just going to hold Control Shift and isolate that square, and then Control Shift again just so I have my cylinders visible. Then scrolling down here to the Polygroups tab, there's a new button in here in ZBrush 4R4 called Group as DynaMesh Subtract. Now I have polyframes turned on, and as you can see when I hit this button, it has now changed the polygrouping of all these objects to this white polygroup. The white polygroup is new inside of ZBrush 4R4, and when used with DynaMesh, it's going to give you a subtractive option. So if I hit Control and Shift and bring back my plane here, and then go up here to DynaMesh now, I'm just going to DynaMesh this quick. So I'm going to change my resolution to say something around 768, and turn my blur down to 0, and then hit DynaMesh. And so now you're going to notice that anything that was grouped with that white polygroup is now subtracted from my object. As you can see here, this process has given me extremely complex shapes extremely fast. So carving out these cylinders into this square would have taken me a long time in other programs. Now you can use this option here using the polygroups group as DynaMesh Subtract to punch holes in whatever object you want. ZBrush also has another feature that allows this to kind of be generated automatically with subtools. So if I come to this subtool here, you can see I have a second one here that is a series of squares that kind of have tapered edges. Now I want to punch these squares out of this shape as well. Now so I could merge them together and then group them with the group as DynaMesh Sub and do that process over again that you just saw. But ZBrush has put a faster way in. If I come here and to the object that I want to subtract from the main object and just turn this subtraction icon on. Now having my main object selected, if I come now here to merge down and merge those objects together, you can see that it has already assigned that white polygroup to that merged object that I merged into my main shape. And so now, since I already have DynaMesh active with this tool, I can literally just hold Control and drag and re-DynaMesh the mesh, and it's going to punch those holes out automatically for me. So now with our holes punched out, one thing to notice is how clean these actual shapes are. I'm not going to have to go back in and do any additional sculpting on this actual object. It's done. Now people were going to say that, ZBrush has had this kind of feature of punching holes out in it for a while. And yes, it did have this feature called remesh. The problem with remesh was that you would still have to sculpt or clean up the sculpt after you punch the holes through it. With ZBrush 4R4 and the new DynaMesh Subtract feature, that cleanup pass is no longer needed. You're now getting these precise, complex shapes that require no cleanup instantly inside of ZBrush. Continuing on, I'm now going to demonstrate how to use DynaMesh Subtract to create a real-world precision object. So here we have a Picatinny rail. Now, for those that are unfamiliar with these, they're often used in the military as a mounting point for various devices. So soldiers in the field will have these on their weapons, and they'll use them to mount optics and grips. They'll have them on their helmets to mount cameras and strobes, and then also potentially on their belts and holsters to mount flashlights or other lighting equipment. Now, this rail is an extremely precise object, and before DynaMesh Sub in ZBrush 4R4, it would take a while to model them in other 3D packages. So to start on the actual rail, first thing I'm going to do, I'm just going to come over here and select a simple Cube 3D object and just draw it on the canvas. And then I'm going to come up here to Texture, and I'm going to go to Import, and just import a image of a Picatinny rail that I found on Google. And I'm just going to select that quick and just throw it in the spotlight so you can kind of see what it looks like. So it's just schematic. It was a quick schematic from NATO. You can see we have the front view of the rail, we have a top view, and we have a side view. Now, for modeling purposes, we're primarily going to use this front view here, and then this side view. And we should be able to get all the little details that we need to create the actual rail and make it look exact and match as accurate as possible to this actual schematic. So I'm just going to close Spotlight. Now to start off, I'm going to come here and I'm just going to actually just move this panel over here, close this material window, and then go to Draw, and just click this button here and drag it over to the side. This is going to allow me to just dock that menu and reference it quicker than actually having to come up here and click these every single time. So here we have our simple poly box object here inside of ZBrush. Now if I turn the floor plane on, you can see that over in this draw palette here that I dragged over here, these options lit up. And so basically these options now allow you to add images to the front and back planes and up, down, and left and right planes of the actual floor inside of ZBrush here. So if I come here to front back and then click on map 1 and load that rail file in, you can see that in that front and back plane here that the floor consists of, we now have a schematic. The schematic drawing is now applied. So we can use this to kind of change our object to fit the dimensions of these actual pieces and create it as most realistically as possible. Now if you notice here, if I go to the front view here, you can see that the actual polycube object is in front of the schematic, and then if I rotate around, the polycube is behind the schematic. Now you can see there's these tiny little dots that are going to get rendered when you rotate around the back of this object. If you come down here to the modifiers section of this tab, there's this back dots and front dots. So if you want to get rid of them, just simply click back dots and it will now go away, and now both sides will have no dots on them. It's just a way to tell if you're looking at the back of your model versus the front. For the case for this rail, the front and the back look pretty much identical, so we're just going to turn them off. Now, as you notice, the schematic, the actual front view is way out here to the side. Now, I could take this Cube 3D object and just kind of move it over and then start modeling on it, but that's a little bit, it's a little bit of a pain. So basically, to fix this, or actually take the schematic and crop it to fit our object, we can just come over here to this Adjust button. And when we click that, it's going to open up this window, and this window is going to allow us to crop our image to crop that back grid to fit a certain part of the image rather than the whole thing. So if we want literally just this part to show up, we just isolate that part, and then when we hit OK, it'll go back and only this part will be on that front grid floor plane. Now one thing to note is that the front grid floor plane is a square, and so in here we'd want to keep this box as square as possible. So you can see we have a crop width and a crop height here that we can actually change to make sure that this square is a actual square. Now one little trick you can do is find the object you want to kind of isolate, and then literally just isolate the half of it and then the top. And if we come up here now with the widths already kind of set, we can now change the crop to match the width. And what this is going to do is just kind of square it out and make it that perfect square shape. So now if we hit OK, and we see that now that back face of the actual floor is now a perfect square, and it matches just that isolated section of our diagram. And so now we're going to continue and just literally work on this cube here. Now, one thing you may notice is that this schematic may not be perfectly centered. So if I put on the polyframe here as my object, my polycube object is perfectly symmetrical in the scene. So if I turn X on, you know, I have symmetry left and right. But this actual grid plane isn't symmetrical. As you can see, this horizontal line that's going through this object is a little bit off from the center of the object. So we want to make sure that this schematic matches the center of this object. So to change that, we're just going to come back over here, and we're just going to slide this horizontal offset here until we get that line matching roughly the center line of that object. And you can do this both vertically and horizontally. You can even rotate it if you want to. Now, the next thing to note is that this square I want to kind of use as my starter shape. So I kind of want it to, you know, fill to the extents of this actual schematic. So I'm going to change the scale here on the schematic until it actually fits inside the plane. And then you can see we're a little bit off here, so I'm just going to change the scale a little bit until I match roughly, you know, the cube roughly matches the outer portions of this actual schematic.